This is probably the easiest part, right? We have some default radius, 1 kilometer. If we cannot find, we just extend it.
So can you reliably handle 1000 requests per second with a single service? The problem, though, is that you need to reliably request a payment and then get to know that the payment was completed. Welcome back to the Architecture Weekly YouTube channel. Today we're having another system design interview with Igor. Igor doesn't know the task, but by the cover of the video, you already know that today we're designing Uber. So, ride-hailing service, a mobile app, you can order a taxi, grabs you, and gets you to your destination. So, yeah, let's start designing.
I would probably like do Uber clone. Yeah? Start with kind of writing down requirements, I guess.
All right.
But at which stage we should design it? I mean, it's like early startup stage, which covers just one city or one country, or already.
So, the setup is that the company just founded. We need to design it, but we need to pay attention that in 3-4 years, we're gonna be scaled up to half of the world.
Okay, so basically we need to kind of uh, solve issues which are most important right now, but keep in mind some scalability in the future, right?
Yeah.
So it's probably just one city, right?
Let's start with one city and see how we can evolve it to support multiple.
Mhm. And what is the population of the city would be? So is it
Uh,
like a Melbourne or
let's start with London.
London? Okay, London. Well, if I'm not mistaken, it's something like 25 millions with
Yeah,
suburbs.
yeah, probably.
Makes it smaller. And okay, so it's one city, 25 millions. What else do we need? Initial stage. So I guess
So for traffic patterns, obviously during the day you have the most with peaks at the mornings and in the evenings because
yeah,
people
I
are
think it's
going to
like
work. Yeah,
rush hour,
going back to work. Yeah,
rush hours,
exactly.
and what else?
Yeah, another.
And holidays.
Yeah. Another point is public holidays, especially Christmas or Halloween or any other local holidays where the usage of taxis surge.
Do we handle only like ordering the taxi, or we? Well, I mean, Uber obviously installs some G. Well, but I think the drivers had their own app, like mobile app, and then Uber tracks everything to show the user where the auto
Yeah,
is.
yeah, yeah, yeah. But yeah, basically we need both app so that the driver can sign up and start making the rides, and same for passengers. And the passenger should be able to see where his or her driver is.
Mhm. Oops. Okay, so from already these requirements, we can for sure say that we will need some kind of geo location service just to, and yeah, the both apps, let's pick the same color for now. Driver app, and then user app,
Yeah, it's typically called rider app.
and some order service just to track everything, and obviously payment service.
What kind of payments will we support?
Uh, well, I mean, the typical make it as much easier for the user as possible. We
Hmm.
definitely don't want to prevent them to give you money. So, but yeah, I think we can. Let's be modern. So, crypto,
Okay.
like
That,
conventional, credit cards. Yeah, like
yeah.
conventional banks transactions,
Yeah, Google Pay, Apple
and
Pay.
integration with some third-party service like PayPal.
Okay. Okay. Have you seen any taxi service where you can pay with PayPal? I haven't seen, but Google Pay and Apple Pay is pretty popular.
Well, I, well, I myself are kind of stick to this one usually, so I haven't paid attention to that. But I mean, if we can integrate PayPal as well, so why not? It shouldn't be as much more complicated than, let's say, having a Google Pay or Apple Pay.
Okay.
I guess. Apple Pay. I mean, this is somewhat a desired list of services. Obviously,
Hmm.
doesn't
Hmm.
end up with everything, but we are in an imaginary world now, so why not trying to take best of out of it, right? And with this,
Let's talk. Yeah, let's talk more about the requirements. What else do we need from the requirements perspective?
well, I mean, I don't want to go deep right now in any of those boxes because, yeah,
Okay.
obviously inside it, it's kind of complicated. Well, not a complicated, but at least every one of those would be probably typical microservice, right? So its own database, whatever, load balancing, maybe multiple instances, and so on and so forth. It's just from the use case perspective now. So
Okay.
basically, we need then to identify scenarios. I think we can take one or two or three and then map those to some numbers. So, for
Okay.
instance,
Okay.
when there is a
Yeah.
peak,
Let's.
how much instances of, let's say, order services we need, and how critical it will be to, let's say, have a single database instance already shared, and things like that.
Okay. Okay.
So I would maybe then switch the color and say, okay, we have, let's start from the user perspective. So user talks to user app to make an order,
All right.
makes order. Then this guy talks to order service, and this goes to, let's say, geolocation service to gets the list of nearby drivers.
Okay.
Once it's get it, it's basically sends a request to the driver. So to accept the order, right?
Yeah.
To me, it
Sounds.
seems reasonable right now, right? Yeah, sorry. Well, then one of the driver accepts the order. So we send everything back to the user, basically. I'm not trying to think whether we need confirmation from the user. Usually, I think it's not. Well, I mean, there is still possibilities to like cancel stuff or not, but I think once driver accepts it, for user it's kind of automatic. And then, yeah, we execute the order. Let's say we track it here and just do some push notifications.
Okay. Do you need
Um,
any additional services for that? Like, how are you gonna send a push to a mobile app?
push to the mobile app. Well, I haven't
And
used
how do you
native
make?
mobile apps, but if I think about, let's say, web-based applications, that would be a WebSocket. So, yeah, I think it would be a good idea to have some kind of notification service as well.
Hmm. Okay. Well, if the application is closed on either user or driver side, then you will need to send a platform push notification, and that should be done through either a third-party service that will handle it for you, or directly through a push notification service correspondingly to Apple and Google.
Yeah, then these guys definitely talk here. In a sense,
Okay. So order service basically handles the whole life cycle of the order. Is it correct?
the order service, you said?
Yeah.
Yeah, this is will be like the central, the heart of the application, so to say. Yeah, and then in the end, it's basically how I can basically request the payment.
Do you want to know how to design proper software systems? Do you want to grow to a senior or staff engineer positions? I developed a business oriented system design course specifically to achieve those goals. We're gonna learn how to identify and gather the requirements and also prioritize them, how to address performance, security, reliability requirements, how to document software architectures, and how to make architecture decisions. The course consists of 10 lectures, 10 home tasks, and a final work. You're gonna receive the graduation certificates by the end of the course. All the details by the links below the video.
Yeah, there is another important feature which is like ratings of everyone. So I think we
Okay.
should think about that as well at some point. Ratings. I'll just put it aside for a moment. But the idea, yeah, after the payment is done, or the service might talk to this guy as well to request a rating from, let's say, both for user and for driver. So I think this somewhat covers like the basic scenario from the user perspective.
Okay.
And then I think we have now like two options. Whether we try to map this to some numbers, taking it into account that we are in London and some rush hours, or write another scenario. I think it's more interesting to go into the numbers, right?
Yeah. I see a lot of problems that we will need to solve there, but yeah, let's talk numbers.
That was a bit demotivating. Okay.
Well, you need to make sure the notifications are actually sent. You need to make sure that the payment is not failing, because if you don't do this, you will lose money. There will be edge cases where you can't find the nearby drivers. And what is the radius that you search by? What does this nearby mean? Right? There are a lot of questions that we need to handle later.
Yeah, of course. I mean, we can do that as well. Probably will be a third option because, yeah, every one of those guys should provide some kind of SLA, and this should never fail, so to say. This has to maintain some persistent queue for the messages and provide some delivery guarantee for sure. Well, not some, but well, some really strong delivery guarantee, if it makes sense. Yeah, this is probably the easiest part, right? We just if you don't we have some default radius, let's say 1 kilometer or 3 kilometers, and if we cannot find, we just extend it. So, and this I think is like least important one.
Okay.
We quickly write it down. So they very dumb thing like never fails, and this fails. This provides strong delivery. But I think we can simply buy from some third-party company, maybe. I want to, let's say, implement our own algorithm. Let's see.
Okay. Okay.
Yeah, so,
Okay. I have some questions. So first of all, this order service, does it single-handedly handle all the user requests?
well, in this scenario, yes, because we kind of investigated the user order scenario. But I
Okay.
can see that, for instance, we could have some other requests, let's say, going directly from the user to, let's say, rating. I don't know if
Okay.
they just want to see their own rating and it doesn't make sense to send it via the order service.
Okay. Okay.
But I just don't want to pollute this diagram a lot,
Yeah. What I'm trying to make you think about is, do we probably need additional component to route the user requests from the application to appropriate services?
I would initially maybe abandon simply into the user app. It's
Okay, you're gonna expose
like,
different services to the public, right? So the mobile app will have the links to the different services. Are you sure? What are
well,
the pros and cons of this solution?
depending on I mean, definitely yeah, interesting question. So basically, what you're trying to say is that we need some kind of, let's say, gateway API.
Yeah. I would like to have a gateway. To clarify here, what's concerning me is that imagine you have order service, then rating service, then you will add some more, like for geolocation service because you need to send real time updates about your location and so on. Uh, then you say, okay, I don't have only production; I have a staging environment as well. So what do? You're gonna hard code every service address there and update the application every time. That would be like suboptimal. Okay, that's
Mhm.
first thing. Second thing is that there is no authentication authorization here on the scheme. That would be nice to centralize too. So API gateway can help with that as well. So there are a lot of arguments why we actually need API gateway here.
I agree. Yeah. But you mean this will be not a Kubernetes gateway API? It's gonna be like our specific.
I don't know. Like you suggest what technology do we use for gateway? How do we run services? What is
Mm.
the compute there? Why a particular solution would fit best here?
Well, it depends on, let's say, our capabilities. But I think since this is a startup, most probably they will just buy some cloud infrastructure. And the cloud infrastructure, I think nowadays it's almost mandatory to have a Kubernetes there. So, and it also will ease the transition from one cloud to another because with Kubernetes, by the end of the day, it's just a number of YAML files, right? Which you can easily port from one Kubernetes to another. Well, maybe not
What,
easily, but
yeah,
it's a bit easier. So I
yeah.
think we should
What
target
will what
Kubernetes.
will be the reasons to change the cloud if we optimize for that?
Whatever they change their pricing scheme, for instance, suddenly.
Okay, okay.
Yeah, so I mean, that's just, but the thing that comes from top of my mind is basically pricing. So you
Hmm.
might find some, yeah, basically that's it. And maybe there are some other constraints. I don't know. Maybe
Okay.
they do not fulfill their whatever reliability agreement, things like that.
Okay.
I mean,
Okay.
along the way that you are using it, there might be real issues. But the most realistic probably would be price change and trying to cut the costs.
Okay. Okay, let's do next things. We have a gateway API, but we need to fulfill the security requirements, obviously. Like, not everybody should be able to call our APIs, so it should be protected somehow. How are we going to solve that?
I think we will need some authentication authorizations to arise. And this, in its way, can be integrated with some third party,
Do you know any examples? What can we use as a third party?
like Google or Facebook. I mean, the
Oh,
identity
okay.
provider. Identity
Okay,
provider.
identity provider. All right.
Yes.
That should be external thing, right?
Yeah.
So
So it
what I see is
should.
that we need, yeah, we need some color coding here.
Mhm.
So some kind of like web applications, then backend services, then external services, something like that. Also, yeah, what would you like to dig into?
Yeah, as I said, for me it would be interesting to map this onto the numbers so we can kind of estimate, let's say,
Okay, let's do that.
what are the capacity planning would be for, let's say, orders or rights, for instance. And yeah, do some math, which I'm not really, which is not like my just skill, so to say. So what I'm trying maybe to, I don't know, become maybe, well, let's consider some rush hour time. Rush hour. So how I would calculate that? So we have roughly 25 millions of population, right? And then it's interesting to estimate how many of them will actually try to use our service.
Let's assume, I don't know, 10%.
So it's 2.5.
Yeah,
million.
in 1 hour, let's say.
Yeah, so we need to downscale it to whatever FPS per second. So requests per second. So it's gonna be like somewhat 1,000 requests per second,
Yeah, probably.
which is not much actually.
Yeah, it's not million, but we're not doing high frequency trading, right?
Yeah.
So can you reliably handle 1,000 requests per second with a single service?
Well, I would tend to say yes, but it would be at the edge.
Okay, so let's make it more reliable then.
Well, basically just 2 instances would be enough.
Okay. How we gonna balance the traffic between them?
With such thing, yeah, well, just taken a well-known solution, and let's say for simplicity's sake, let's just say we're gonna be round robin.
Okay. Do you want to have API gateway and Nginx in a single service, or you want them to be different components?
Well, that will be a different components, yeah, because this is, let's say, our specific application, and
Okay.
this is just a pure Nginx where we take Nginx conf and write, okay, we have this backend, whatever upstream number of gateway instances, and just do a round robin with them and some other performance settings. So I think,
Okay. Okay.
yeah, with 1,000 requests per second, because I'm thinking now about technology which we can take, and I did some performance testing of web applications with like Node.js, Python, Rust, and Go, and with like let's say more or less compiled languages, we can easily achieve 10k per second. Well, not easily, but with some either CPU bound or IO bound load, we can reach 10,000 per core somewhat easily. So 10, so we have kind of 10 times more
Yeah, the capacity.
here. Yes, with with the scripted languages like Node.js or Python, it's 5,000. So still quite a lot
Yeah.
of
Okay. Still pretty serious
extra
for.
extra capacity here. So I think in this case, it's if we go with just some simple standard solution, which is the better. That would be my way of thinking.
Okay. What's next then? So how are we gonna guarantee the things that we have here about the payments, about status updates?
Yeah, that's more interesting. With status updates, we so it's more about choosing the right technology, I think, in this way. So we can, I mean, the most like standard way will be probably go with Kafka. Although I would like to, since we're in imaginary world again, if we want to try something new, I would go with Apache Pulsar, which persistent stuff and some level of guarantees, and also a lot of potential for scalability, yeah, already embedded.
Okay, let's mark it on the scheme that we're using some kind of a queue.
So it's, I don't know, is it the best way to just put a comment here, or let's say, okay.
I think it should be a component between the order service and push notification service, because push notification service it's not it's
Yeah, yeah,
Pulsar, it's a
yeah,
client for Pulsar, right?
I,
So
I agree, yes. Just deploy the extra component here, so let's move things around a little bit.
okay, so that's about push notifications. Let's talk about the guarantees for payments.
Well, that's an interesting piece, so to say. Well, I'm personally never worked with payments,
Okay,
frankly speaking. So my first intent would be to maybe buy some third-party service.
It's fine. Typically, what you do is you partner with some PSP like ADN or Stripe or anything else. The problem, though, is that you need to reliably request a payment and then get to know that the payments was completed. So this is the challenge. So imagine we have this PSP outside of our solution, but then payment service should talk to this PSP. Okay, because typically what you want to do is you want your payment service to tell this PSP capture this amount from this user's payment method. This is how it works. And the problem is to make this communication reliable so that we don't lose the payments. Okay, how can we do that?
Well, I don't know. Maybe it's a dumb solution, but if we just put here some conventional relational database like
Okay,
MySQL or I don't know Postgres,
okay, and then what?
then we can kind of save and update uh, communication messages, so basically transactions in the database. And then we can guarantee that if this guy, let's say, took the money and then made a transactional commit into the database, then some
Uh,
order has some consistency and all that stuff.
yeah. How it works typically is that you have some kind of HTTP API like capture, so payment service can tell the PSP capture this amount, and then obviously PSP can capture actually the money, but fail to tell you that it was captured because how it works again, you expose a webhook, and they will tell you through this webhook that yeah, money were captured. What if you were not available? What if the payment service were not available while the PSP is telling you this? So what do you do?
Yeah, again, my idea was to actually update the database and then payment service goes to the database to see the status of the payment.
You cannot force the third payment service talk to your database.
But
Doesn't
yeah,
work that way.
so the webhook.
The webhook. Okay, webhook. Fine. All right. And then what? Like the PSP typically would try to call your webhook 3 times, and then if it fails, it would just stop.
Then we need to, and well, can we enhance webhooks? I don't know. Maybe we will need some kind of uh, some sort of small API here in front of the database,
Okay.
which will monitor those kind of things and basically provide a timeout or yeah. So it either receives the message from the payment service or it waits for a timeout and then assumes that transaction has failed. Roughly speaking, maybe there will be something else.
Okay.
So some sort of how I would call it. Let's see, front end.
How the status model will work for payments then?
Sorry, once again.
How the payment status model will look like?
So some kind of sequence diagram, right?
Yeah, probably. Or status diagram. State machine, let's say.
Well, I'm not sure. Other guys provide us with some extra metadata whether the payment was kind of accepted. No, I mean it was accepted.
They will tell you the order ID, like their own order ID, and the status, like failed or captured successfully.
To the webhook, or you need to.
Yeah, to the webhook.
Okay, and we can assume that this combination is reliable. So we.
No, you cannot assume that. That's the tricky part. That's why I'm asking this question.
You are saying that it might be the case when, let's say, we requested the payment and then they actually received it, assigned it the order ID, but never called our webhook to actually notify us that
Well,
there was ordering.
yeah, basically, so they can fail to call your webhook, or
Mm.
they can try to call your webhook, but your webhook would be unavailable because your node was down, or the region where you're running this was down, or there's a network problem, or any sort of trouble. Yeah, there can be a case when the money were captured by the payment side, but you don't know about that. How you get to know?
Well, I mean, will some Boolean will work in this case?
So probably you can just go over to the database after some timeout, like an hour or half a day, and check the payments in the appropriate status and try to request the status directly, and do that until you actually get the real status.
Hmm. Okay, yeah, then it's basically we need some kind of extra service here, which is to the third-party Boolean, third-party payment server.
Okay, I would argue that you can have this as a part of a payment service, but all right, if it like has the different schedule
Yeah,
part,
I
then
mean, maybe I'm not that consistent, but yeah, it can be part of the payment service. But since we are talking about that, I don't know, maybe 5 minutes already,
okay, okay.
I just wanted to highlight it on a diagram so we can put it
Uh,
here, keeping in mind that this might be an independent service or part of the payment service. But idea is that yeah, it's basically pulls this guy and kind of maintains consistency in the our database. Oops,
okay.
something like that.
Okay, so let's talk about the storage as we started talking about the databases. So, what databases we will need to store like users, orders, and stuff, and how much storage we will need.
Okay, yeah, that's an interesting question. I mean, following the trends, it's kind of there is an desire to, let's say, use some documentary database here. Let's say for users and drivers information, we can use conventional SQL database.
Okay.
SQL for users and drivers. I don't think, well, maybe if I give it more thoughts, I would end up with document-based database, but let's for now assume we have this conventional database. And then for orders, for orders, for orders,
What kind of
so
guarantees
it will
you?
be enough just to have some kind of key value database where key is order ID and value is current status, or maybe some additional metadata.
Okay.
So
What kind of guarantees you would like to have from this order database?
guarantees, well, it should be like super reliable because on that's actually our payments. What else? I'm trying to understand if we need any like performance, extra performance here, because it doesn't feel like this will be updated way too often. It will be updated. I mean, every individual order. We might add orders, remove orders quite fast, like this fast at least, somewhat, right?
Exactly.
But every individual order won't be updated that much. So it should be like read oriented.
What? Why? You're gonna change the status of orders as well, right? So
But
created,
it's not that
accepted,
frequent.
finished.
It's just create order, then it takes real maybe even minutes, definitely. Well, let's say seconds, sometimes minutes, definitely not milliseconds to update to the next stage.
Hmm.
And then while we're driving, it might be, let's say, half an hour. It's doesn't update at all, and
Okay.
then it's kind of just finished. So, I
Yeah, yeah,
mean,
but do you,
way
do,
too
you,
simplistic
eh,
model, but
yeah, but do you query the database for this order during this half an hour? Like, what's the necessity for that?
well, actually, no. I
Mm-hmm.
don't think we need to query it on a regular basis. It's only when we write in updates,
Yeah,
creating new orders or removing the old ones. And by
exactly.
the way, we cannot remove the old ones because we need them for the history in, let's say, user account or
Yeah,
driver account or for
true,
some account.
true.
So there should be like a hot storage, also some kind of cold storage where we store these old orders. Cold
Yeah, by which
storage.
condition you're gonna move the orders to the cold storage?
It's done. It's already, well, maybe, let's say after 20 or 48 hours, I think it's already eligible to move it to the
Okay,
cold storage.
okay.
Depends actually. If we, it depends on whether we have business users. I mean, who is ordering taxi from the business account,
Mm-hmm.
from the company account, or it's just private. Because if it's private, it's rarely when they are interested in the history of orders, right? But for the business, once they come to the, let's say, destination point, probably they want to then do some reimbursement formula,
Mm-hmm.
formula or something like that. So
Yeah, we don't touch on the invoicing thing because like we're not creating any documents regarding this. But actually, that's a whole subsystem where you need to create invoice for driver, invoice for rider. If you're working with the business, it's business invoices once a month. Also, the invoices for commission invoices for drivers like once a week, and a lot of other stuff.
yeah, yeah, yeah. But I mean, we can pull those from the cold storage anyway, because well, once a month it might take 5 minutes. Yes.
Oh, okay, okay.
So I would say it's safe to maybe move orders. So we will have somewhat like 2.5 millions an hour records. And
Okay.
if, let's say, wait for 2 days, then it might be quite a significant amount. So let's just move it, I don't know, after 5 minutes when its order is done.
Okay. My next question would be like how this design will change if we say, okay, we expand to another 100 cities all over the Europe.
100 cities all over the Europe. Well, basically, we can just replicate this for each city more or less because it's super rare.
What we're gonna,
When,
yeah, what we're gonna replicate exactly? The whole system?
well, ba- obviously the order services, the
Hmm.
storages. Yeah, let's for simplicity's sake assume that we more or less replicate everything. Just we start a new city, we take our, let's say, YAML files for Kubernetes and just deploy
Hmm.
it closer to that city.
Okay, but how many cloud regions you have in AWS in Europe? I don't know,
uh,
a dozen.
two or three, I think. It's like one in Frankfurt, I know, maybe some.
Yeah, there's Frankfurt, there's Stockholm, there's London, there's US central one. It's Zurich, I believe, somewhere in Switzerland.
Mm,
So yeah, it's 4 or 5 regions.
yeah, not much. Yeah, sure.
So you won't be able to do this a region per city. It's more like region per cluster of cities, I would say. Right?
Yeah, right.
Okay. Let's talk a little bit about the security and let's wrap up because we're running out of time. What security measures we're gonna apply for data in transit and for data in rest?
I'm sorry, what?
Do, do we apply any encryption for, I don't know, between the user app and the engines? Do we encrypt the data that we store in our databases? And what measures do we apply?
Well, definitely we wanna like an HTTPS here at least. Here.
Okay. Any requirements on minimal SSL version, TLS version?
The Mozo beta, I believe, the latest one is 1.3, so
Okay.
it's gonna be the case. And yeah, well, with the database, it's tricky because yeah, if we talk about Europe, we have to take into account all these tons of regulations. I think that at some point it would be easier just to maybe buy third-party servers to handle that.
Okay. You're not gonna serve everything by the third party because it requires the right for deletion, a right to get your data, and so on. It's like something on top of the database and not the database offering itself. But
I don't know. Maybe we'll just put it in GDPR. Sure, nice.
Okay. Okay, so we're running out of time. So thank you very much. I think we designed some kind of a viable system. There's always room for improvement, indeed, but I think you managed to achieve some viable state that you can write a ride-hailing service with that. Folks who watching it on YouTube, let us know what we can improve on this diagram, and don't forget to smash this like button so it helps to run the channel. Thank you very much.
Yeah,
Thanks, Igor.
thank
Yeah.
you.
See you later. Bye bye.